All right, so happy Thursday. So we're gonna get started on some stuff that I think you've already seen this again. Hopefully this week has just been kind of review. Great. So and you don't have to worry about actually writing your name on a sticky note or anything like that. Which equation could represent the graph? Okay, so I want you to kind of think about it. Which one could represent the graph? Okay, so if I look at this one, okay, then this point right here is probably positive and then negative. So we know that it's going to be negative over here. So we can go ahead and eliminate this guy. Okay. Just as a reminder, your setup for the I'm losing all the words. Radicals are x minus h plus k. Okay, so my point where it would start would be h comma k. So in this instance, it's got to be positive underneath here. Okay, so that would be something like this or this. And it seems kind of far down for the most part. And it's kind of close to the y-axis. So I'm going to say that it is C. Okay, now I guess you could kind of say that it's B depending on like the scaling of the graph, but right now I'm going to go with C. Okay, abstract reasoning. Okay, just a reminder on some of this stuff is which equation could represent this graph? Use the equation to find the key characteristic. Okay, so the domain would be from, and we use C, right? So it's going to be the square root of x plus 1 minus 5. Okay, so our point for our domain is going to start at -1, and it's going to go to positive infinity. Our range is going to go from -5 to positive infinity because it's going up. Our end behavior is as x approaches positive infinity, y is approaching positive infinity. And we could also say for the left-hand side, as x approaches -1, y is approaching -5. Rarely will you be asked about that, but that's going to the left-hand side. It's only increasing. So we're going to say that it's increasing from -1 to positive infinity, or you could say from negative infinity to positive infinity. That's okay. And we're not going to have a level of decrease. Okay. So today, we're going to just identify key characteristics of radical functions, connect the graph to solve a radical equation. So you're going to complete this document. If you are missing, I know a lot of y'all have been asking about assignment 3 and assignment homework 3 and all those things. I think that was like right before Ms. Yao left. So if you're missing one of those, this is kind of what it covers. But if you are missing one of those, just bring it to me and I'll grade it. But I want you to complete this practice. Okay, so just make sure that you right click, open in a new tab. You can work in a group. The group can only be a group of 3. I saw some people who were in a group of 5 last time we did groups. So please make sure that you're only in a group of 3, okay? And you need to all be working together, but you're going to complete this on your paper and you are going to turn this one in, okay? So again, you're going to turn in the graphing, stick it together, modified, okay? So that document is right here, okay? All right, going back. Okay, using graphs to solve equations, using the graph to find solutions of the following equations. Okay, so if I looked at the y value when x is -2 on this one, when y is -2, what's my x? Well, that's -8, okay? And the cubic root, or when you take -8 and raise it to the 1/3 power, that's going to give you -2. Okay, so we can actually solve using the graphs. If I subtracted 2 from this side, I would get -4. And so I'm going to look at when y is -4. Well, it's way off my page. Okay, so I would probably want to use my calculator and then cube both sides because that's going to be way off my graph. Over here, I'm going to look at when x is negative, I'm sorry, y is -2, and that gives me -8. But then I'm going to add 2 to it. So that's going to be -6. So x is going to equal -6. Hey, you're good. You're fine. All right, let's try this next one. So use the graph of b equals square root of x to find the solutions to the following equations. So if I took the this equation right here, the square root of x equals 4, I'm going to square both sides. So that would mean that x would equal 16. So look at this. When x is 16, y is 4. Okay, so that's how you would use that graph. So again, I would square both sides on this one. So x would equal 25. Go to 25. Look at what y is, 5. Okay, you do the same thing for this one. So x would equal 5. X is 5. It's right there. Okay. Right. And on this next one, it says use the cubic function. So I'm sorry, this is quadratic function. Label the points on the graph that shows the solution to the following equations. So if I took the square root of both sides on this one, that would be x equals plus or minus 5. Okay, so that would be here. It's always super hard to see. There and there. Okay, if I squared both sides on this one, t would equal 25. Okay, so t is going to equal 25. Hey, give me 1 second. All right, so if I took the square root of both sides on this, I would get s equals the square root of 5, and that's going to be positive and negative. So the square root of 5 is roughly 2 point something. So it's going to be like right in here and right in there. Okay, and this one, if I square both sides, I'm going to get t equals 25. And those are going to be a little bit off the graph. Okay, moving on to that last slide. In your notebook, take about 2 minutes, identify key characteristics of radical functions, transformations of radical functions, and using graphs to solve equations. So summarize what you learned today in your notebook. So remember, you're turning in today the stick it together modified. And so you'll turn that in today. Okay, so please make sure that you are working. Okay, all right, see you in the next video.